Okay, so the exams last week looked really good. Both parts, the programming part and the multiple choice or fill in the blank, the question part, I guess, is a good word for that. And also on a couple of recent quizzes, I did finally get around to going through the last couple quizzes and putting points back on those. And there was two things that I had noted to put on the list of things to mention that seemed to be a bit misunderstood. So I wanted to make sure and clear that up in the videos here. The first one, there was a question about buffers. I can't remember if that was on the exam or in one of the recent quizzes. I think like 2/3 of the class selected the option that was saying, thinking a buffer was a temporary file. And a buffer is not a file. I wanted to make sure and clear that up. Files only exist in storage. Files are like preserved things. We take our data and send it over to storage to keep it. A buffer is just space in memory to hold transfer data. So that doesn't make much difference at this course, but in the long run, that will make a difference. Such as for you, Jerry, working with networks and servers, that's going to be a big difference because what's in the buffer can be lost. We can lose that completely if there's like a power failure or something because it's not saved anywhere. It's only sitting there in memory. It's just something to speed up the process. So what a buffer does is we have something coming in from a source. I'll try to draw a picture here. And then instead of going right to the file, maybe that's what we're using, whatever our source is, I'm just going to use a file for an example. We could send it right through there one bit at a time, right? 1 0 0 1 1 0 0 1, and have all those bits flowing one at a time into that file. A more productive, a more efficient way of doing that is to stick a buffer in between to kind of collect all of those things. So instead of going right to the file one bit at a time, we collect a bunch of those bits and then send all of those over in one big swoop and then fill this up again. So it has some advantages, but the main thing is one of the choices on the quiz that I think about 2/3 of the people selected that option is a buffer is not a file. It's only temporary storage in memory, and we have control over how big it is. We would say do 64 bits at a time in the buffer, or do one line of the file at a time in the buffer, or 1024 bits, and we can control how big that is, and then we read it. It's like temporary storage on the way to wherever we're sending it between our source and our destination, just to consolidate things. And that way, there's some other stuff more advanced that we could work in there, but we can check that along the way. That way we don't have to wait till the very end to make sure all the data came through correctly. But the big thing at this point is a buffer is just a space to hold things. It's never an actual file. So it's all in volatile memory. So we could still lose the data that is in the buffer. That was one of the things on there. The other one that I made note of was with try catch or try except blocks. One of the questions, how did they word that? I think it was in a quiz and not on the exam, but it was it was something about requirements for this. Like we have to write specifically what exceptions we're trying to catch. Like it say that if there were 4 possible exceptions, we'd have to write 4 exceptions for an in-out exception, a file not found exception, or whatever the situation was. But one of the answers was that we had to write specifically for that exception. And there is no such requirement like that. There's not really any requirements on the try except catches. We could do just try and accept and don't say anything about what type of error we're trying to catch with it. And then that would just catch every error. The only times we would need to be specific is if we wanted to give the end user a particular message to adjust whatever caused that error. Like a file not found error, we would catch a file not found error and then throw up maybe the browse dialog box so that the user could go find the file that the program couldn't find on its own. So we only need those specific cases if we're going to do something specific with it. And there's really not any requirements. In general, with Python, this is all at the programmer's discretion. Some languages, there are requirements, such as in Java. If we want to open a file, we cannot open a file unless we have error. It would be try catch there, but we have to surround it with error handling before it will even let us attempt to open a file handler. But there's no such restrictions in Python. And a lot of people like to often just use the if-else blocks in Python. The main thing is there's no particular requirements for how we use these. It's all at the programmer's discretion. And we can use just a piece or the whole thing or several other pieces. I just wanted to mention that because I think about 2/3 of the class had missed those 2 that really caught my notice. Is like a lot of people had missed those. Enough of the class missed them that I'm going to go back through the quiz or exam or wherever it is and give everybody that point back. Because obviously there was a misunderstanding somewhere along the way. So I wanted to make sure and clear up that point. Those were the only 2 that really struck, that I really noticed as being a problem. There were a couple other questions that I just did not like in general. I think there was one quite a few people missed that it gave some little example code and asked what was going to happen or how many times the loop was going to run. And from what they gave what was given in the example code, I didn't use the quiz. I didn't write the quiz. I just used the one from the statewide module. But what was written in the example, it would have definitely crashed and not run at all. But running 0 times was an incorrect answer. I think almost everybody picked that it would run 0 times. I went and put that point back on there. There were a couple questions like that, but the buffers and really stuck out to me. Buffer is not a file. A buffer is entirely in volatile storage. If it was a file, that is safe over in storage. We can recover it from storage, but we can't recover it from volatile memory. So that's a big deal with buffers. And with try except blocks, there are no restrictions. It's just personal choice how you want to use those. So I wanted to clear up those points. And the other thing, sort of the main content for this evening is, well, everything we've looked at so far has been in Python. And this isn't necessarily a Python course. So I wanted to talk about some other languages. So I was going to do that this evening, go over a couple other languages. I have brought these down for an example, some books on some language books, just to make sure the point is clear. Because I've heard people say that before, like, this is an introduction class, we're just using Python for the introduction. So these books are all about the average size of a language book. And here's our book. And you can kind of see the language book is a whole lot thicker. So this is Visual Basic or C# book. Kind of hard to hold those next to each other. I can get them on the camera, but you can see the language books are quite a bit thicker than the book we're using for this class. And these big, thicker books don't have a lot of explanations and stuff. A big chunk of our textbook is explaining what a selection structure is. All those pages and pages, and then several examples of using it. The actual language books there, which are 2 or 3 times thicker, books don't have quite as many explanations on stuff. By the time you get to that, it's kind of read those books, it's expected that you know what a selection structure is. So they just go over a bunch of stuff about selection structures in that language in particular. So I wanted to clarify, make sure that point's clear. This isn't a Python course. So to exasperate that, I wanted to look at a couple other languages. Well, at the end, we're going to look at Visual Basic. So that would be one of my first picks for alternative languages to look at, but we're going to do that on week, I think 7 and 8. We might get into it a little on week 6, but the last 2 weeks are in that. So we'll see that there. So the other one that I wanted to go over thoroughly, or not really thoroughly, go over quickly is, I was thinking we'll take a quick look at PowerShell, some of the scripting functions in PowerShell, and basically everything we've seen. Is what all have we seen so far in Python? We looked at just our basic, just some basic in out, the very general throw up a prompt, get some input, write stuff back on the screen. We looked at variables, selection structures, loops, functions, some read and write files, and arrays. I think that's everything we've looked at. Is that some? Does that look? You notice anything missing there?
I think, is that tuples would that fit in the arrays?
Okay, yeah, yeah, tuples, list, arrays. I should say collections, because we didn't actually look at arrays because we don't have arrays. I'll put list and tuples. But that's kind of what we looked at, and we took a little bit of time to talk about the meaning, what each one is here. We spread it out over, like these two were the first week, the second week, third week, fourth. Yeah, so we spread that out over 4 weeks in Python. But a lot of that was the concepts. So what I wanted to do was to show how these concepts apply in other languages. And I'm hoping this is going to be a confidence booster. So my hopes for going through, because we're going to go through these very, very quickly in another language, is what I wanted to do. And PowerShell is a useful thing. That's Windows PC control. Are you on a PC, Jerry?
Yes. Yep.
Okay. Yes. So you'll have PowerShell and be able to follow along. And my hope is that this will be a confidence booster. When you see these same things, and it's just a different syntax, but they still interact in the same way that we've been doing them in Python, it'll boost your confidence and help make it feel like you've learned a little bit more. Because I definitely remember how sometimes school seems like it drags on and on and on and on. Especially things like programming, where we get into the details and all those explanations, and it makes writing an if-else block takes an hour and a half. But there's some reason behind that. So hopefully now you'll be able to follow along, and in 45 minutes or so, see the syntax for another language and be able to do all the stuff that you've done in Python so far in that other language, just as just as well. So I'm hoping that's going to help be a confidence booster, but at the same time, we're going to do that in 45 minutes. So don't let it shake your confidence, because obviously if that doesn't work out like I'm hoping, then that was way too quick. It takes more than 45 minutes to learn the language. But I'm hoping you'll see how this applies in other languages. We'll go all the way through PowerShell, and we might, depending on how long that takes us, we might jump online to this online IDE I know about and look at a couple other languages as well. I'm going to go ahead and share my screen and start kind of working through some of these. Kind of working through those things that I just put on the board in a different language. And yeah, part of the reason I chose this one is because it's the control language for Windows. So obviously there's the command prompt, the old DOS command prompt on Windows, which has been around since the 80s. And back in the 80s, memory was a very precious commodity. So we certainly didn't want to waste memory on programmers who knew what they were doing. So all of the instructions were abbreviated. But by 2000 or so, 2000, 2005, it really wasn't necessary to abbreviate everything anymore. So they did an update, and all those old abbreviations still work. Any old DOS command prompt instructions do work in PowerShell. They didn't delete anything, they added to it. So if you know the old instructions, those still work. We'll look at PowerShell. It's the updated version of the old one. On Linux systems and Mac, because that runs very similar, there's not really an updated version since the old one. There's people have been working on some things, but there's nothing official yet. And a lot of people, to get the full scripting with something more modern than what was written back in the 80s for those 70s and 80s for those machines, have started using Python. But that is a little bit different, because Python is software that sits on top of the operating system and can just access it. Whereas like PowerShell or working directly in Bash, we are directly in the operating system, not sitting on top of it. So there's nothing official on Linux yet. But when I was looking around last spring, originally preparing my notes, lecture notes here last spring, I did come across on GitHub where several different people have created translators for PowerShell into Bash. So you have the full modern scripting language that Windows put together for PowerShell, and it just automatically translates that into Bash commands. So if you're on a Linux machine, you can download one of those translators and use this just as well. So I'm going to start and show that it's, show this just for an example. When I migrated from doing everything locally on my machine to doing most stuff on the cloud, I wanted at least a little interface to work with here on the machine to consolidate stuff. So I wrote this little program here entirely in PowerShell. Once it opens, there it is. So just a little GUI. This big space right here, I'm migrating to the cloud. So this is for a browser window, but I was not very happy with the browser window that was available in the package I used to put the graphic user interface together. So I'm modifying that and creating my own to go in here, and I haven't quite finished my own browser window yet, but that is coming. I took the Chrome engine, the core part of Chrome, and then just customizing it to my needs instead of the general all-purpose fit everybody's needs. So that's what goes in all this blank spot, and then just some shortcuts to get to like Docs and Sheets and Drive, where my online databases are, banking stuff, the school stuff, just some quick shortcuts, which right now just opening Chrome. So like all the Ivy Tech sites, so my Ivy and Ivy Learn. What's the third one? Oh, and then the tutoring schedule. So just a quick, some shortcuts basically put on buttons on my desktop because all the software that I'm using is actually on the cloud. Excuse me. And that way I don't have to type in all the addresses. And I believe next week we're going to get started looking into some graphic user interface stuff a little. Maybe a little on Wednesday. But one thing, a tip I was going to point out is a button like this when you're developing things. I've stuck this button in here just for development, and it opens the actual code for this software to make it easier to edit it. So here's all this stuff written in all the PowerShell instructions and the code for this window, which the library I used here is the same library we will look at with Visual Basic on week 7 and 8. It's just on Visual Basic, we'll be using Visual Studio, so we'll be dragging it around with our mouse instead of typing it. But that dragging around with the mouse just writes a file. Kind of like we saw with Python, that we can write text files very easily. So we could write a .py file and have one Python program write another program. So when we drag our mouse around when we get to Visual Studio, it just writes the Visual Basic file in the background. It just writes out the text and then puts a .vb extension on it. So when we're doing that, if you go into the packages and look, you will find the typed up code for the interface you put together. So just a little looking ahead there, but so you can see we can put together nice our standard graphical user interfaces with all our menus, and there's not really much here except the shortcuts. So the same buttons there, and is it down here? Yeah, if I right click on it, I have the buttons down in the tray at the bottom. So all the standard stuff done in PowerShell. But for us, we're just going to look at this short list. These same things that we looked at in Python, just a whole lot quicker. So I have it here on my taskbar because I tend to use this a lot. But if you just go to the start menu and look for PowerShell, you'll see 2 different versions. Well, you'll see several versions. There's the basic Windows PowerShell. So let's start in that one. And here in a minute, we might come back and use PowerShell Ise. That is an IDE, a full integrated development environment. So that's a much better editor to use. But let's just start in the regular Windows PowerShell prompt, the prompt-like version. So I guess, oops, my notes turned sideways. I always hate when that happens. I should turn rotation off. There we go. Because I'm going to be throwing the tablet onto my notebook quite a few times in the next few minutes. So let's just go down this list. The first thing was the basic in-out. So our keywords, the equivalent to print something on the screen is just going to be write. I guess the standard hello world. And that's going to echo back to the screen. And just like we saw in Python, if we type that directly in the string, while we're in the prompt, we can type that directly in. But if we tried to do this in a script that we save and then run later, it's just like it would be in Python. You know, typing it in the prompt shows us that number, but unless we say print in that script, it's not going to print back to the console. So write is the keyword for that, and notice the lack of parentheses. So we'll look at functions in a moment, but that's our notation for that is we have the function, and then instead of wrapping the arguments in parentheses, we space delimit our arguments. Or we put a space and then start putting the arguments in a comma in there. We'll see that in a moment when we get to functions. But the word write is equivalent to what we were seeing as print in Python. And is it read from?
Is the echo command any different from write?
Nope. Just an alternative. There are a number of them. Echo is the traditional DOS command prompt, what we would type. So actually, one of the big things is we'll have get help. So if we do get help for echo, we'll see those are aliases for the same function. So write was just the, oh, and also there's the write dash output to spell the whole thing spelled out. So that's an important one there too, is we can just type get help and then type in one of our keywords and we'll get all the instructions. Might as well look here. I was going to do this on a new file, but to go over how to read these help things. So we have the name of the function, and then in square brackets is a parameter. So square brackets are the parameters we can fill in, and the angle brackets are the type of thing we will use to fill in those parameters. So like input object and no enumerate are the parameters we need to fill. And one of them will be filled with a PowerShell object. So that's basically the generic type, just anything we can put in PowerShell, a string, a number, an array, anything that we can work with in PowerShell can fill this input object parameter. No enumerate, and then just common parameters, and that means that type is going to change depending on what this type is. So that was a little bit more complicated example. Read from, is that the name of it? What's going on with my keyboard? Uh-oh, can you still hear me, Jerry?
Yes, yes.
Okay, my internet flashed off for a minute. So the window is called the host. So we can just do clear host to clear that out. And the equivalent of the inputs, like we saw, is that's going to be read host. So read whatever the user types into the host window, basically. And then that takes in one of the parameters we can fill is called prompt, and things are space delimited. So read host, and then our parameters all start with a dash, and then the name of the parameter, and then we put a space to type in whatever the prompt we want to put is. So like, I don't know, a standard one, enter a name. And this is one thing that's nice about PowerShell compared to some other prompts, is usually we have to put that symbol at the end and all that spacing and stuff. But notice I've closed the string immediately. And when that prompt comes up, it put in the semicolon and a space for us, because it knew it's going to be a prompt. I always kind of like that part. When we put in the name, and since we're in the shell, it just echoed back. But so the equivalent of print is either going to be write or echo. Since you asked about that, probably use echo if you're already familiar with that one. And read host, and again, we could do get help on read host and see the aliases. So there is no alternative to the read host. That's a new one for PowerShell. there wasn't an equivalent back in the day. So here, read host, and then one of the parameters is going to be this prompt that we can take in. Host. So that's our basic in out. I'm going to use, for the example here, I'm going to use write and read host for the equivalent of print and input in Python. The variables, so PowerShell is a $sign. I call them $sign languages. All our variables start with a $sign. So I'm going to put the string world in here just for an example. So anytime we have a variable, it's open type like Python. We just give a reference name for our variable, and then equal to whatever value it's going to be. And every variable has to start with a $sign. And one of the really nice things about $sign languages is it comes in concatenation. So if I wanted to write that and write hello space, and what we've seen so far is concatenation, we'd have to actually stop our string, come out and add it. But with our $sign languages, the languages where the variables all begin with a $sign, we can throw that right into a string and it will concatenate for us. So if where variables start with a $sign, when we need to concatenate our string together, we just throw that variable right into the string. It makes concatenation a whole lot easier that way. So I'll do a couple numbers. So like X is 3, then Y is 4. And notice how I wasn't reading that as $X equals 3 and $Y equals 4. When I was thinking about that, I was just thinking variable X, and then the $sign means it's a variable. So I was thinking just X equals 3 and Y equals 4. That way it's kind of, and the $sign just kind of comes along with that thought. So there's a couple numbers, and then we can do math with them, obviously. So like a Z variable equals $X plus $Y. Just add them together, and we have all of our regular operations. Same symbols we use in Python for our operations here. So there's no change from that. And we also have the assignment operators. That was another one that I almost went back and talked about, put on that list of things from the exam or a recent quiz, is don't forget about the assignment operators. It's things like X equals whatever it was in X times the number in Y. That sort of stuff shows up a lot, right? We are reassigning the value X. Reassigning the value X based on what it previously was. So there's a shortcut notation that we have in Python. So that one we could do times equals. And that's called the multiplication assignment operator. Kind of a mouthful there, but saying X multiply assignment by Y is exactly the same as if we said X equals X plus Y. I'll put a comment in here. Exactly the same as X equals X. Whoops, I said plus that last time. I meant times. Sorry. The multiply assignment is the same as if we did X multiply assign Y is exactly the same as if we did multiply X equals X times Y. Oh, and then comments are the pound sign again. Same comment symbol we use in Python. So then if we just pull up what X is, you can see it took what the value that was in X, 3, and then multiplied it by the value that was in Y, 4. And yeah, that's for, so the math operations are the same. So for the main thing for variables and doing math is just remember every variable has to start with a $sign, which can be really, really useful. I'm going to skip out of order on this list, and I'm going to jump ahead to writing files, because since we're in a basically a prompt for our language, writing writing files is a little easier than the selections and loops. So we'll come back to that in just a moment. So to write files, our keyword is new item. Well, first off, we need to change the directory, because right now I'm in my top level directory, and well, you've probably noticed in class I have this folder called delete, where I do all the temporary stuff. Yeah, where I do all the temporary stuff to just make it easier to clean up my hard drive every few days. So I want to change the directory to that. So the old command prompt one was CD, short for change directory, or the updated version, the spelled out one is set location, which that's a lot of the new instructions are just, they're not abbreviated. We actually spell it out, which at first seems like a lot, but it's kind of nice because then we don't have to memorize what every function does and how to abbreviate it. We can just spell out what it does. So as we get used to it, it does make a lot of things easier. And back in the 70s and 80s, when the original command prompt was written, it was very important to abbreviate things. We didn't want to waste memory on programmers or anybody that would be that knew enough to be working in this stuff. But there's plenty of memory to go around nowadays, so we can spell things out. And typing is not hard. Don't be lazy with typing. And well, this is the one I was set location, and then we pass in the directory. So from where I'm at, I'm going to go into the documents folder and then the delete folder and work in that directory. Whoops. Oh, I spelled location wrong. Set location, documents / delete. But I figured one of these was going to show up before long since I'm typing and talking at the same time. So this is what the error messages look like. You can see it's very descriptive, like what we were getting in Python. So in PowerShell, it starts out with the problem. So it had no idea what this is. So the term is not recognized. It's not the name of anything it knows. Check for the spelling, check the path you're on. It gives little tips for what it might have been. So this one didn't, but sometimes if it's really close to an instruction, it will give a suggestion on what it should have been. It's like, okay, that's not recognized, but it's really close to this valid instruction over here. So some of the error messages will have almost like spell checkers in their grammar things. But just like we saw in Python, you just kind of have to read through that and figure out what problem it's actually pointing to. So let me try that with set location spelled correctly. There we go. So now I'm working in this directory. And I'm going to clear host again, because this does kind of fill up quick in a prompt. Oh, and the up and down arrows will scroll back through the previous commands. So we can get back to anything we've typed in recently, and not just this session of PowerShell. So that was on the old command prompt. You know, we'd open that up, type in all the commands, and same thing on Bash, terminal on Mac. We open it up, type in our commands, and we can scroll up and down to the last few we've gone through. But when we close the window, those are gone. In PowerShell, we can scroll back to the commands from the previous sessions as well. I don't know how far back it goes. Obviously, there's going to be a restriction on that, but I was doing some stuff the other day, testing some things in Python, and I just kept running them with PowerShell, and I was able to close the window and just open it back up and scroll back up to the previous ones. So the up and down arrows do go to the things we've already typed in. So the next thing, I'm just going to go to creating a file and writing words to a file. We'll go ahead and look at that. So it's going to be new item, but this is the one I was originally thinking about pulling up the get help. So get help on new item. So the old way of typing that in, if you do want to be lazy with typing and know that it's NI, you can type that just as well. And notice here in our syntax, we have, it's overloaded. There's more than one version of new item, and they take in different parameters. The first parameter is the path as a string. So that's the path we're working in, which if we're already in this directory, the only thing we need to add to that path is the file name. So new item, and then we have a path argument to fill in. And if you weren't already familiar with it, Windows is not case sensitive. So it doesn't matter whether we use uppercase or lowercase letters. Windows is not case sensitive, but in things like the variables we create, just like in Python, it will be case sensitive for our variables because that's how we set to name it.
Is there a way to specify to get help on aliases? Because for some reason, aliases doesn't show up as a section under my get help. I have like description and related links instead of aliases section.
Oh, I'm not sure. Get help aliases.
Like I didn't know if you could do get help like new item and then aliases of that or something. I'm not sure.
It might be on mine because I use aliases a lot, especially for database stuff. If I'm going to do like MySQL stuff right from here, you can check Google real quick. Aliases not showing up in PowerShell get help. Get alias. So there is actually a function for it.
Okay.
So we can do like get alias or new item. Did I spell something wrong? Oh, well, actually, that one might have to go with set aliases. Let me scroll down a little here because we can also set the aliases. So set alias for new item. To, I don't know, I'm going to do something like this. So now if I do get help, so notice when I change that, I'm getting a new get help feature.
Mm-hmm. Looks a lot different.
Yeah. So it is very dynamic. So it might be because I've changed aliases before that it adds into my general get help, or it might just be a different version of PowerShell. because if they've updated and removed that. But you can set your aliases to anything you want. So just set alias, the thing you want to rename, and then what you want to rename it. Do you think would be easier to type in? Get help, new. Hello. Get alias, new item. We'll return all the aliases for that. I might have accidentally just replaced that in I. So it is a little bit dynamic. It is dynamic. It does change as we do things, which has its advantages and drawbacks. Yeah, now I don't think I can get back to that get help when I was looking at, but there are going to look at, but there are a couple things for new item, which I think I can still type in I. No, it recognized what I was doing, but it, yeah, it tried to bring up that other thing. So I'm just going to spell it out. It's a new item, and then one argument we have to give is the path. And we're already in the directory I want to work in, so all that's needed is a name for the file, which will be a string. And then what type of thing is it? So item type. And item type is either a directory or a file. So this is just going to be a text file. I'm going to try this real quick. I'm going to restart PowerShell and hopefully it got rid of that alias. Okay, yes, so I just restarted PowerShell and then we're right back to where I was. I'm not sure what was going on, but I'm going to use, so looking at one of these, we need to pass in a path argument, the type of item we have, which will either be a directory or a file. We only really have two types of items we can create. We can pass some words in, but I'm going to come back and do those. So I'm just going to do new item. The path to it will be test.txt, just some text file. Oops, I gotta go back. Sorry. Set location to documents/delete folder. So I'm gonna go back in there to where I was working. Now create a new item and a path from this folder, go into just some name for the file. Item type. And notice if I type item type, whoops, it doesn't change colors like it should. It doesn't change to gray to indicate it's an argument. So all of our arguments do start with a dash. So dash item type will be a file. And then when I hit enter, got this little message saying created one file there, a length of 0. And if we look over at the directory, we have that file now. There's just nothing in it. So we could do it all in one step, but then to read and write from a file will be set content and get content, which now we have to type the path in every time. So to abbreviate that, I'm going to go ahead and create a variable called file path that has that whole directory. So C, users, Chris, documents, delete, test.txt. So just a variable holding that whole, the whole directory path. That way I don't have to keep typing that stuff over and over and over again. And that, the reasons for that should be kind of obvious, right? There's a lot of room for typo in that long address string. Or just typing the file name over and over again. You know, if we go to a different directory, we still have the whole path right back to that file, so we can work in it from anywhere. So then to write to a file, we set content, and the path we're going to write to is stored in that variable file path. And the value we want to write to it, well, it's a text file, so I'm just going to write some strings, some random words to write to the file. And just pass in as a string something to go to that text file. Which, notice there was no feedback on that. If there was an error, if something would have gone wrong, it would have put an error message. So we could come over here and look at the file and see it just kind of wrote the words right in there. Usually I start with writing and reading files in PowerShell because that's more of a command prompt thing. So that's a straightforward thing. And then to get the stuff is going to be get content. We fill in the path argument to say what we're getting the content of. And well, to read what's in the file, we don't really need any other arguments. So just get content and then what file are we getting the content from, which I saved as that variable to make it easier to retype. And you can see it just threw those words from the file right back up there. So there's the reading and writing files.
Does Linux commands work in here, like bash commands?
Some of them do. And if you're more familiar with those, you can just do like that thing I did a minute ago that kind of messed up my help menu and stuff, and set the aliases to those instructions. I don't know which all ones do. I have encountered some that are definitely Linux commands, but it's definitely not an exhaustive list. So maybe they're working them in there in case people know them, working them in as aliases or something. But I have seen some that work. And again, you can always rename. You can always put an alias on any of the Windows functions and just give it the Linux command if you know those. So what else is there? Read write files. Okay, so I guess the next thing on here is our selection structures. So we still have those variables X and Y, I think. I'm just going to put a couple, I'm going to put them back in here. Y equals 4, just to have some variables to work with. So the if selection structures is just the keyword if, and then in parentheses we'll put the condition. So like X is, I don't know, greater than 10, but they didn't use the normal greater than symbol. So we actually have to pass that in. It matches our syntax for a parameter, and it's like -GT for greater than, or -LT for less than, -EQ for equal. So it's kind of spelled out. So greater than maybe 10. And then we put curly braces to signify the block. So in Python, we use the indenting to signify the block that goes with the if structure. So here it's just using curly braces. So if whatever's in X is greater than 10, I don't know, I'll write X is a big number. And then we close the curly brace. And if we hit enter at this point, it would go ahead and run just that one part of the if structure. So if you want to type else, the else needs to go immediately after that closing curly brace, kind of on the same line, something like that. So if some condition, do this, else, I guess, right, X is a small number. And then once we hit that closing curly brace, oh, and then it is if else spelled out as two words. If you need that, the nested structure. If, then else if as two words, and then curly braces to surround what to do. So X had a 3 in it, so X is, so it went to that else structure. And then just to show the other one, I'll do that thing we did earlier. So X, multiply assignment by Y. So now X should be 12. If we multiply a 3 by 4, and I'll just scroll up until we get that if else back in there, which at this point we could edit it. If you scroll up and down, you have the ability to edit them and then hit enter. So that time it hit the other condition. And if else is spelled out as two words. Otherwise, the idea of a selection structure is just like we saw in Python, where we just write, the if, instead of elif, we have else if, the non-abbreviated form, and then whatever we want to happen, just wrap that in curly braces to signify it goes with that if part. Loops are very similar. I'm going to clear this again, clear host, and loops are almost we have a while loop, which is almost identical to Python, except we're using the parentheses, which parentheses do work in Python, but I think our textbook uses spaces, so I was using those in Python, but just the keyword while, and then some condition that we want to be true. While X is greater than 3, and the condition in parentheses, and then in curly braces, we do what we want to happen. So I'll write X is $X. And then once again, that concatenation thing, the languages where we start, all variables start with a $sign, we don't have to do anything special to concatenate it. We can just throw it right into a string and it'll recognize that. The trade-off for that is we need an escape sequence if we actually want a $sign. That's the backslash, like on the line feed. We do \n for a new line, or \b for a backspace. If we actually want a $sign in a $sign language, we have to do the \$, or like \quote mark if we want to put a quote mark inside of a string. So write that, and then $x, subtraction assignment by 1. That'll work. And then close curly brace, closing to signify what part goes with what to do when this condition is true. All that makes sense so far?
Yeah.
And I'm going to do for loops in just a second because we have 2 for loops. In Python, we actually only had what is normally called a for each loop, but we do have a regular for loop here as well, which those typically go with arrays. So I'm going to start by making, well, I'm going to call it my array, but again, that's the word we say because it's a list here. And to create one, we use the @ symbol and then parentheses. So all of this is kind of like this, what we were doing with square brackets for a list in Python. We could put all the stuff in there at once, or if we start with an empty one and add them later, we can just do an empty thing. So @ and then parentheses to signify that there's a spot there, and that'll create an empty array. And then I'll add some numbers to it. Yeah, so we have regular for loops, which are the ones we use numbers for. So we're going to have some variable to track in this for loop. We'll start at 0 because our array indexing starts at 0. So we'll start at 0, and then we need a semicolon here. And we're going to go while that variable is maybe less than 10. So I equals 0. I stands for index. That's kind of a very common one to use. The index for our loop, and we just say I for index. So I starts at 0, while I is less than 10, we want to increment I. And this is a very common one that we don't have in Python, that a lot of languages do, is something that shows up more than any other increment operation is increment by 1, right? Like I equals I plus 1. So that shows up more than any other. So if we do I plus plus, that means that's the shorthand for increment by 1. And that works in a lot of different languages. So that it's going to start at 0 and just keep looping until we're less than 10 and increment each time. So a for loop has all 3 parts of what we need in the loop built into one. This is hopefully you can see the difference there between the for loops in Python. Because for for loops in Python, we had to have some structure to walk through. But here, it's all 3 parts of what we normally need in the loop. We have an initialization. Where do we start at? We have a condition, so we know when to end. And then we have an update, so that we know what to do so that we eventually reach that ending condition. So a for loop is just the syntax for consolidating all those into one. And I'm going to go ahead and do just random numbers in there. So my array, and there's lots of overloading going on in PowerShell. That means more than one function for the same symbols, and the computer will know what to do. So to append stuff into the array, in Python we had to do .append, but it's overloaded, so we can just do the addition assignment operator. So the array, I guess in this case, it's going to be append assignment, which means we're going to add something else into that array. And we have a built-in function get random. So just going to add in a random number with parameters minimum of say 0 and a maximum of 100. So yeah, just some random number between 0 and 100. And then we can go into closing curly brace to close that off. And this should fill up our array. So now if I go print my array, or just really echo it back, you see we have a bunch of random numbers in there. And this is we also have for each loops, and this is the type of loops we're actually working with in Python. So we can do for each, I'll call it element in my array. Is in the right word? Yes, in. That's slightly different in every language. So like for each element in my array, I'll just write something, right? The next element is element. So does that make sense, Jerry?
Yeah, it's kind of the same with the end on the same as the Python there.
Yeah, yeah. And you see how there's two different types of for loops? We have this one that does all our conditions about a loop, and then here we have for each thing in some structure. So those are our three types of loops, the while loop and two types of for loops. For these conditions or for this array, this collection, whichever term we want to use for that. So what's left? So that's like list and tuples. It's actually a list, just like we were using in Python. We just say array. I guess that's supposed to flow off the tongue better or something. So functions would be the last thing. I'll go ahead and hit clear host again. And to do a function, well, we just throw in this keyword function, and then we give it some sort of name. So I'll call it double. Oh, yes. I'll call it, whoops, because now it's called double. I'll call it double, and notice that I did not put a $sign on that. Whenever we call this function, you'll see the color coding that it gives our functions. So the functions, actually all those things we've been doing, those are functions. So like new item, write, and echo, all the things that turn yellow, the yellow stuff is functions. So we don't need a $sign to start with that. We just put in the keyword that it's going to be a function. And when we're designing our function, defining what it is, we need parentheses for any parameters that we will take in. So I'm going to take in something called x, which just like we saw in Python, now even though there's a variable called x outside, while we're inside this function, we have a local x that it's going to use rather than that outside version of x. And then curly braces to signify what's inside of the function. I said double, return 2 times x. And then a closing curly brace to end that. So the keyword function, a name for it, in parentheses, any parameters we need to pass in, and just comma separate those. And just like Python, if you have a default value, you can put equal. So we could have done like $x equals 1 to put a default value in there in case something didn't get passed in. But then when we call it, well, those ones we've been calling are functions. So it's just like that. We'll type in the name, and notice the color coding. It's yellow now, so it knows that there is a function called double. And then a space to pass in any parameters. So we'll call double and pass in maybe a 5. So when we do that, it's going to return a 2. And obviously, just like in Python, if it's a void function, just leave off the word return. Just do stuff, but don't send anything back. But if you do have something to send it back, you probably want to put that somewhere, right? So like normally we would do, when we call a function with the returns, we want to put that somewhere. So D is going to be this function double with maybe some random number put in there. it brings that back. So then if we write the result is D, we can work with that variable like normal. So is that everything on that list? Our basic in out, our variables, our selections, loops, functions, reading write files, lists, and tuples. So see how much quicker that is when we just look at the syntax? Compared to the first, 4 weeks of the class?
It's a lot more easier to carry over.
Yeah, and the logic applies the same way. That's why we only have to study the logic once. And then for any other language we want to work in, we just check the syntax for it. They're kind of set up similar. And I guess to save a script, I put a small example here together. So there's 2 places. I was just going to do it in Notepad++, but our other PowerShell thing here, I should probably point at that. I pointed out there's the PowerShell Ise. Do you see that on your computer, Jerry?
Yes.
So that is a full IDE that has like the predictive text while you're typing and a big menu with help functions and stuff built in. You see over at the right, we have a list of all of the PowerShell commands. So you can just kind of go through there and get a sense for those. And then we have a text editor part right here, and then we have our shell down here to run what's in that text editor. I'll do a really quick one in Notepad++. So just the standard, right? Hello world. And then for a PowerShell file, we save that with the .ps1 extension. So example.ps1, and if I look at the directory, you can see it gave it the PowerShell thing. If I open PowerShell, to run that file directly from PowerShell, what we do is we go to the location. That location, I put it in my delete folder. So documents delete. And then we can type // in the name of that file, which I already forgot what I named it. Example. So // example.ps1 is what we call to run that directly in our shell. I just wanted to show that really quick because a better place to do that, instead of, if you're going to save it, instead of doing it in Notepad and then running it manually with the // is working the actual IDE that has the predictive text. So that's when I put write, we get this nice long prediction of everything that has the write. So it's actually write output. Hit tab to get that off the list. So write output, hello world, kind of the standard there. We'll start with this, and then we'll save it somewhere. And at this point, it saves as just it saves exactly the same as it would if we typed it in Notepad++. I'll call this another example. And since we're in the IDE, it added the .ps1 extension. So kind of a better place to do it, but we have a little green button to run it. Or we can just push F5, which is typically the standard. Most of our IDEs across all sorts of different languages, it's usually either F5 or F6 to run the program. And sometimes if we hold Shift and hit whichever run key it is, Shift and the run key will run the one we're looking at. So if there's lots of files in our projects, we can run just any one of them in particular that way. We can come up here, click the button, and well, that's what // means. The // means the directory we're in. So you can also just type the directory and then run that. See through the messages up here. So I'm going to clear this out and do a really quick example of things like what we've seen in Python. Actually, one of my fallback examples, I'm pretty sure we've done this in class a couple times, a simple tax program. So I'm going to start by just echoing that to the screen. Right. This is a simple tax program, sales tax, a simple sales tax program, just to echo out a label for that. And the rule of thumb, I'm going to type the rest of this, a few more lines before we run it, but a good rule of thumb is you want to run a test every chance you get. Script you're about to run will be saved, so yeah, go ahead and auto save it. And the first line ran, so I'm not necessarily going to do that on this case, but when we start writing functions and selection structures and things, it's always a good idea to run a test every chance you get. So what do we need for, I guess, a tax rate? Tax rate is it 7%? Yeah, I think that's about right for Indiana. I had to think back to a couple trips to the stores. Seems like I should know that after a lifetime of living in Indiana. So we have our tax rate. Then when we get the price, so price is going to be that thing we saw very quickly earlier, read host, which the predictive thing is nice because computers never make typos. So if we just do enough to get it on the list and then hit tab, the computer never makes a typo like humans do. Read host, and we're going to throw up some sort of prompt. And for a prompt, I guess like, please enter the price. But this is going to face that same problem we have in Python all the time, right? When we do input in Python, what's the problem we face with our input?
We may have put it in wrong and the computer can't tell.
Yeah, if it comes from the keyboard, only strings come from the keyboard, right?
Like a logical error or something.
Yeah, but price should be a number, so we'll need to cast it. So I'm going to wrap all of this in parentheses because that whole thing is going to return one value from the user. So I'm going to wrap it in parentheses, and then our casting is in square brackets, we'll type we put the type of thing we're casting it into. So we're going to throw up this prompt, get a number from the user, and then turn that into a float. The same logic we've seen in Python over and over again, right? It's just a different syntax, but it's still, the programming language behaves in the same way. And now that we know for certain that's going to be a number, we can do math with it. So let's bring in tax. And tax is going to be the price multiplied by the tax rate. And again, I'm selecting from that predictive list as much as possible because the computer will never make a typo. And if it does, it shows up very quickly in debugging. So unless you're the one debugging it, it will never make a typo. And if you are the one debugging it, you will notice it very quickly and fix it. And then I guess we need a total. Total equals price plus the tax on it, which we can just scroll through the list and then hit tab to select it. And then we're ready for some output. Right. The total will be, and then whatever's in that total variable. And it's a $ language, so we don't have to worry about concatenation. We just throw our variables right in the string. So I'm going to hit Control S to save that. And when I run it, hopefully that's all going to work. So we get that title, a simple sales tax program, and enter a price. So $5, the total would be $5.35. That sounds about right. If we give it another run, check a few numbers. So this time maybe a price of $5.43. Didn't quite come out so nicely as $5.35, right? I had this on my example that I prepared earlier. I wasn't sure whether to show it or not, but if I remember correctly, you were one of the ones that were using printf from the very first week, right, Terry?
The F strings?
So to format our numbers, I'm going to go ahead and do it here as a reassignment. Because I remember you were doing that the very first week, so I will go ahead and include this part. It's kind of messy notation. We need this weird looking string. So as a string, we get a curly brace, 0:N2, and a curly brace. So that part is a string. Then -F for format, and then the variable we want to format. So this is kind of like we were seeing with the Python list. Because remember, well, really, all this data is stored as bits. So we can always treat it as an array of bits, if nothing else. So we're going from bit 0 up to 2 spots past the decimal place, and just reformat that number. So that's what that syntax means. It's kind of a messy thing. It's hard to remember what all that means, but currency is not too bad of one. Those do get messy very quickly. But currency is not a bad one. So 0:N2 inside of curly braces as a string before we do and then right before we push -F for formatting. So kind of a messy thing, but if we save that and run it, and what number did I enter that was kind of like that? 543. So say a price of 543, and then it formats that nicely to 2 decimal places. Oh yeah, and then it's a $ language, so if we actually want a $, we have to do an escape sequence. Wait, did I do that right? I might need to. Nope. The escape sequences are the grave accent. Are you familiar with that key? That's the thing below the tilde, the apostrophe that points the other direction. So our escape sequence. The tilde key without pushing shift. Right next to the one, that little apostrophe, that is our escape sequence. Backslash means something very particular to Windows. So Microsoft decided not to use backslash for our escape sequence. So we used the grave accent. So like new line is grave accent N instead of \N. I think that's right. Yeah. And since $ means something, $ means variables, we need an escape sequence in order to actually type a $. Does everything about that make sense?
Yes.
A very quick pass at the language. But you see how everything that we've studied in Python just jumps right over there, and all it is slightly different syntax. I just wanted to go over that. That took a few minutes longer than I was thinking. That was pretty much what I had in mind for tonight, because I wanted to leave plenty of lab time to mess around with this. Like always, I will leave my computer here in my gym, not in my not in my office, with the lights on and everything until 10 o'clock, the normal time. If you want to kind of mess around with that and look at stuff, and if you have any questions, we can jump back on Zoom, and like my computer will be here, so you can just send me a message and it'll beep on my phone, and we can jump back on Zoom if you have any questions. But I wanted to make sure there's plenty of lab time. And so if you want to do some homework, if you want to turn in some whatever assignments you can instead of in PowerShell rather than Python, that will be fine this week, because this class is about the programming. It doesn't matter what language we program it in. I'm fine with other ones. It's just we went over PowerShell. I wanted to include this because this is a very useful one. But a whole lot of our languages follow that same logic. They go together in the same way. So once we see one language, we should be able to jump right over to another one very quickly just by seeing the syntax. The only significant change is we will see that on week 7 and 8, and that's because we'll be working with Visual Basic there. And Visual Basic is a strictly typed language. So we have to say what we have every time. If we have to have a string, we have to tell the computer it's a string as soon as we tell it, set up that variable. If we have an integer, we have to say it's an integer.
PowerShell.
Have you seen those before?
I think so, yeah, but PowerShell is still a object-oriented, right? Like Python?
Yes. PowerShell is very similar to Python. That's one of the main reasons I chose this one to go over for a second language. It's open typed, object-oriented, just slightly different syntax, but everything will behave in the same way. And if you would like to do any of the assignments in PowerShell rather than Python, just to kind of expand what we know about computers, that is fine. I will be perfectly okay with that. The lectures will continue to be in Python on Wednesday, and then next week, and then the week after that, we will be doing Visual Basic. So then we'll switch languages, but the lectures will still be in that. And this is an incredibly useful language. Anything you know about DOS command prompt instructions still works here. They didn't delete anything. They just expanded it and added in this object-oriented scripting, like what we have in Python. And it's your Windows control. So this is direct control over your Windows operating system. So it's a good language to know. But do you have any questions about that, Jerry?
No.
Okay, yeah, and if you want to mess around with it, this PowerShell Ise, you can see there's this huge list over here that has every function in there. And some of the ones, if you just start typing, oh, actually, this is has a help function. So if we click on things over here, we get a description of it. So it's almost like this language will teach you itself once you get started into it. But if you didn't have any questions, that was all I had for tonight, because by the nature of this, I wanted to leave a lot of time for lab. And I hope that helped to serve as a confidence booster. After stretching Python out for weeks and weeks and weeks, you can see that in an hour, well, it had to have been less than an hour and a half, because I did some other stuff at the beginning. In less than an hour and a half, we went over all that same stuff, detail of all that same stuff in another language. So if you have any questions, just let me know. Otherwise, that will be it for this evening, and I will see you on Wednesday, where we will get started into object-oriented programming, which is nice. Object-oriented programming is where we can think like a human again. Instead of having to adjust ourselves to the machines, we adjust the machines to us. I'm going to hit stop on the recording.